afternoon. I am Alithia and I am a physics expert, and I'm here because I've been investigating the Fast and Furious movies, and I'm here to prove that they don't follow the Newton's law.
Hello, I'm Natia Ortiz, and I'm a character from the Fast and Furious movies, and I have to say that our movies do follow all the Newton's laws, and I'm going to prove it.
And all of the scenes?
Yes.
Okay, what do you tell me about this? First, we're starting from the first Newton's law. Okay, do you see anything wrong in this scene? No? Okay, let me explain. In the first Newton's law, we have the law of inertia that states that every object stays in the same state at rest or at movement. Only it changes if there is another force, an external force, that changes it. So in this scene, we can see that this girl over here, So there's this car that goes over the two bridges and falls to the floor with a tension with a rope. Which, by the way, it's not even physically correct, but that's a topic for another day. So the tank stops, but as she is going at the same velocity as before, her inertia makes her fly over the two bridges within a certain angle. And so this other guy over here, that guy jumps over the two cars and stops the car, but because of his inertia, he keeps on going with the same speed as he was doing in the car. And he went on the exact same angle to grab Letty and go on the car and not break their bones. So that's impossible. Because okay, he going at the same exact speed as her to be able to grab her, okay, going in the exact same angle to grab her, and the car when they crash, it was in the exact same trajectory to make them not break their bones. One of them seems to be possible, but all of them at the same time is impossible, because he would have needed so much physics knowledge to be able to calculate that in less than a second, and that is impossible.
Okay, you're right. Maybe it wasn't possible, but it happened. I'm alive, right? Anyways, let's watch this. So, as we can see, that there are two cars that are pulling on a box, and they're exerting a force on the box. However, later the two cars separate and stop, and the force that is being acted on the cars to stop is enacted on the box. That's why it keeps on moving. So we can see it is a clear example of inertia.
Okay, yeah, in that scene, that law is proven. But look, let's pass to the second Newton's law, okay? First to say, the second Newton's law says that a force is equal to mass times acceleration. So it means that the force is proportional to the mass and the acceleration.
example, there is a race where there are 4 cars. Toretto is in the first car and Ryan is in the last car. And they seem to be carrying the same mass as there's just one person inside each car, and also a similar acceleration as the positions of the race don't change for a long time. However, later, when Ryan opens the nitrogen, there's more force applied on his car, and so the acceleration increases, driving him to the second place in the race. So we can see that this is the example of the second unit.
Okay, in this one it does follow. But there's a third level theorem, and I can put you an example that it doesn't follow it. Okay, this scene. So in this scene, we can see that this girl, Patsy, hits the guy with a crystal bottle of water, or I don't know what it is. And afterwards, we can see that he is absolutely fine. Does he have any cuts on his face? No. And that does not follow the rule of third Newton's law, which is action-reaction. It states that every action has an equal and opposite reaction, opposite in direction and equal in magnitude. So because of this law, he should have all his face full of cuts. But he doesn't. And that is
Okay, you're right. But in the third Newton's law, action-reaction, there are many scenes where we can observe it. And it's in the fight scenes.
in the fight scene, there's also many punches that they don't have arms, but okay.
So, as we have seen in this scene, there were many moments where we can see the third Newton's law. However, we're going to focus on one specific. That's when Luke is getting hidden with the rubber bullets. We can see that when he gets hidden, he throws one of the policemen and starts walking towards the one that's shooting him. While he's walking, he gets shot one more time, and he stops moving and pulls back. Here we can see the example as the action is getting hit by the bullet, and the reaction is stopping and pulling his body back. So you can see that in